Hi all. Now we are going to find out the equation of an alternating EMF. So here, the similar way we are having a rotating coil in a magnetic field, which you have explained in our earlier lecture. Here also we have a coil, and that coil I am naming it as A, B, C, and D. And this coil is having, even though now the coil is having only 2 turns, I am assuming that the coil is having n number of turns. And this coil is being kept in a uniform magnetic field. So I am going to draw a north pole and a south pole over here, north and south pole. So the magnetic lines of force will be moving like this. So it is kept in a uniform magnetic field, and I am having an assumption that the coil is rotating at a constant angular velocity of omega radians per second in the anti-clockwise direction. Now I am going to draw only the coil cross section, that is the coil. When I am cutting this coil at this particular center portion, I'll be seeing it as 2 circles. So those 2 circles I am going to draw it over here. Okay. Now the coil is rotating. So at this instant, when the plane of the coil is perpendicular to the magnetic lines of force, then you can say that the force on this coil is like this, and here it over like this. So you can see that there is both are parallel. Therefore, the flux which is cut by the coil is 0, and therefore the EMF induced in the coil will be 0. The EMF induced in the coil will be 0. So this will be 0 at this point. Now the coil starts rotating. The coil starts rotating in which direction? It is rotating in the anti-clockwise direction, and therefore the plane of the coil, now it will assume a position like this. So basically what happens there is, when the coil is trying to move in the anti-clockwise direction, it is trying to push these magnetic lines of force like this. So therefore the magnetic lines of force which was perpendicular, now it will take to a position like this. That means it starts cutting the flux lines. It starts cutting the flux lines. Now it is at an angle theta. This is the angle theta. So that will be the amount of flux lines which is cut at this particular position. Therefore, what happens? The voltage starts increasing. And when it reaches to a position like this, then the maximum amount of the flux lines is being cut by the coil, and therefore the voltage induced will be maximum. Then it will start reducing. So now we are in an assumption that we have certain assumptions here. N is the number of turns, omega is the radians per second, that is the coil is rotating, and let t be the time over which I am trying to measure the change in position of this particular coil. That is, this is at the instant when t is equal to 0, and the time is increasing. When it has reached t seconds, it has taken an angle of theta. And at this instant, the flux which is linking with the coil will be phi is nothing but phi m cos theta, where phi m is nothing but the maximum amount of the flux linkage, that is at this particular position. Maximum amount of flux is linking at this position, and at the instant of theta it is phi m cos theta. Now let theta be the angle through which the coil is rotated in the time t seconds, which you have already defined. And now we can say that the angular velocity omega is nothing but theta divided by t. That means theta is nothing but omega t. And phi, the flux is nothing but phi m cos omega t, and the flux linkage is nothing but n into phi. That is the number of turns of the coil multiplied by the flux. Then according to the Faraday's laws of electromagnetic induction, E is nothing but minus d by dt of the flux linkage. Negative sign is because of the Lenz's law. And the flux linkage is nothing but n phi, and therefore I can write it as minus of d by dt of n into phi m cos omega t. It is nothing but n phi m omega sin omega t. So this is nothing but the equation for the EMF. It is n phi m omega sin omega t, where phi m is nothing but the maximum flux linking with the coil in Weber, and therefore I can write phi is nothing but flux density B into area of cross section. So therefore I can write as Bm into A, where Bm is the maximum flux density. So this equation number 1, I can again rewrite it as E is nothing but omega n, then phi m I can write it as Bm into A sin omega t. So omega is nothing but 2 pi f, so it is 2 pi f into n Bm A sin omega t. This is the equation EMF, where f is nothing but the frequency of rotation of your coil in revolutions per second or hertz. And when theta is at 90 degrees, that is theta is nothing but omega t. When theta is at 90 degrees, then sin 90 will be 1, and therefore the EMF induced will be maximum. And we can write E as Em sin omega t, where Em is nothing but 2 pi f n Bm. This is nothing but 2 pi f is nothing but omega. We can also write like this. So E is equal to Em sin omega t is nothing but a sinusoidal waveform. So therefore, this is at 90 degrees, this is at 0 degrees. So when omega t equal to 0 or theta equal to 0, the output voltage V is or E is 0, and when omega t is 90 degrees, V will be maximum. Then we can also plot it for 180 degrees, 270 degrees, 360 degrees. So when the coil has completed, this particular coil, when it completes one complete revolution, that is 360 degree, it will be moving from this particular point till this particular point, and this is known as one complete cycle. So how many number of revolutions which it makes, then that many number of cycles can be seen over here. It will be continuing like this. So this is the basic equation of EMF in a AC generator, and the unit of E is voltage, Bm is Weber per meter square, N is the number of turns, and this particular derivation is very important regarding the AC voltage generation. Thank you.